Alright, we're going to take a look at, we're going to take a look at linear programming. It says to solve the problem. So Anita is knitting hats and scarves for her church bazaar. She only has 36 hours available for knitting. It takes her 3 hours to knit a hat and 2 hours to knit a scarf. But because of some yarn production shortages, she can make no more than 10 hats and no more than 12 scarves. She sells the hats for $45 and the scarves for $35. How many of each item should Anita make in order to have the opportunity to make the maximum revenue? So let's take a look first of all at the last sentence. How many of each item? Now that's where, after I read the problem a couple of times, I usually go straight to the last sentence to find out how I'm going to label my variables. So how many of each item? So what I'm going to immediately say is that I'm going to have an X and a Y, and I'm probably just going to make X, not hats, but the number of hats. Now that's important, right? We want to make it sure we're specific to say the number of hats. So Y is the number of scarves then. Alright, number of hats, number of scarves. Now, it says that she wants to maximize revenue. Well, let's go ahead go straight to the things that will give us revenue. Well, she sells scarves for $35 and hats for $45. Now, to maximize revenue, that lets me know that these prices are going to be part of what we call the objective function. We're going to maximize revenue. Well, she brings in $45 every time she sells a hat, which is X, right? And she brings in $35 every time she sells a scarf. And so this is a function that is that is based on how many x's and y's, and so we call this the objective function. It's f of x and y, right? It's determined not just by x, but x and y. So we're going to leave that alone for a minute and notice it's an equation. This is not something we're going to put on the graph as an inequality. Alright, let's take a look now at the rest of this, and we'll just kind of piece together the constraints. So she's knitting hats and scarves for the church bazaar. She only has 36 hours available for knitting. Okay? She only has 36 hours available for knitting, and it takes her 3 hours to knit a hat and 2 hours to knit a scarf. Now, I'm going to show you something that we're not going to do. We're not going to say that x plus y is less than or equal to 36. And why is that? Because x and y are about the number of items, not about hours. Okay, so since the 36 has to do with hours, then we need to create an inequality that deals with the hours. Okay, so she only has 36 hours available, so we're going to say less than or equal to 36. Now, x is the number of hats, but how long does it take her to make a hat? It takes her 3 hours to knit a hat, so 3 times x is going to be the number of hours that are committed to hat making. And then it says 2 hours to knit a scarf. So 2 times y is going to be the number of hours committed to knitting scarves. Now there's my inequality. 3x plus 2y is less than or equal to 36. Okay? Now there are other constraints because there's something about the yarn. They're having a hard time getting all the yarn in the store. So because of some shortages, she can make no more than 10 hats. Okay, now hats are X, right? So we can have no more than 10 hats. So let's just make a constraint there, right? No more than 10, so less than or equal to 10. That's the number of hats. And then the next thing, she can't make any more than 12 scarves. So that has to be no more than 12 scarves, right? There's the hat constraint, okay, in terms of no more than. Okay, now the rest of this we already have put in our objective function. So it looks like we're ready to go. We do understand that automatically we're going to say that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. Okay, we're not going to be allowing the number of items to be obviously a negative. We will allow the number of items to be 0, right? It might be probably not the best choice for a business plan here, but we're going to let the linear programming problem tell us what the best deal is. So I'm going to go ahead and put an XY. I'm just going to use the first quadrant, right? Because I'm not going to allow X or Y to be negative. So this is going to be my X-axis right down here. And of course, this is going to be my Y-axis. We're just going to graph these constraints and see what the feasible region is. All right. So this green line, I'm just going to get my X and Y intercepts, right? X-intercept, Y-intercept. And for that green line, the X-intercept means that I would put in a 0 for Y, and so it looks like X, we pretend like it's equals, X is 12, there's that. And then I put in a 0 for X for the Y-intercept, and Y is going to be what, 18? All right, let me put these points on. X is 12, 2, 4, 6, 8, 10. There's that 12, and Y is 18, 2, 4, 6, 8, 10, 12, 14, 16. Now I'm making my scale, just single units, ones. So now I'm going to go ahead and connect that line. Now in order to be very clear, in order to be really accurate, I'm going to go ahead and see what the ratio is of the Y direction to the X direction. In other words, I'm looking for the slope, right? Because I want to reduce it to the simplest fraction. So I'm going to divide both of those by, what, 6? So that's really a 3/2. So I'm really going to go, it's a negative, by the way, but it's down 3 over 2. So I'm going to go down 3 over 2. Now I should end up where that other dot is, right? Down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2, and down 3 over 2. Good. So what I've done is just said, hey, what's the relationship between the Y-intercept and the X-intercept, which just means that's the slope, right? Okay, there's that line, and of course it's a solid line, and we're going to go, if we look at this line, right, if I get the Y alone, it's going to be anything less than the line, so I'm going to go ahead and shade below. Let's go ahead and do that in green, since I have a green line. Shade below that. Okay, now let's go to the next one. Get that. There we go. So the next one is going to be my blue line, and that's going to be anything less than or equal to 10. So that's a vertical line. 2, 4, 6, 8, 10. There's this one right here. There's that line right there. And of course, less than or equal to. I don't think that the blue and the green go together very well in terms of a highlighter, so I'm going to do cross-hatching to show the overlap here. So there's my less than or equal to 10. Okay, now let's go with the gray. The Y is less than or equal to 12, so that other Y-intercept was 18, so I'm just going to come down 6 from there. 1, 2, 3, 4, 5, 6. So that must be 12. That doesn't look like 12 to me. 2, 4, 6, 8, 10, 12. It is 12. There you go. So there's my line. Y is less than or equal to 12. And I'm going to shade below that. Okay, this time I think I will use the blue, the yellow. Make it faster. Yeah, see that? Yellow is not going through the green. Okay, so that's all right. So now, what I'm looking for, I know that I'm only going to consider, right, anything greater than X or equal to 0, greater than or equal to 0, and greater than or equal to Y. And so my shaded region then, right, is what's yellow, blue cross-hatching, and green. So I'm going to go ahead with another highlighter, and I'm going to go ahead and darken in what has yellow, right, blue cross-hatching, and green. Okay, so this is my feasible region. I need a real clear, I need real clear sets of vertices for these things. Okay, so there's that. Now, I'm going to go ahead and mark my vertices. There's that vertex, there, and there. So, the feasible region has created the vertices that I need to put in a table. So let's take a look at what my table is going to be. My table is basically going to be the vertices here. My objective function, right, which was 45x plus 35y, 45x plus 35y. And that's going to be, my question is, what will be, how can I maximize? Okay. Alright, so I have a point at 0, 0. We're going to start there. There's that point. I have a point at 10, 0. That's the name of this point. Go over 10, up or down 0. I also have a point at 10, 3, right? Over 10, up 3, right there, that point. This point right here is the point over 4, up 12. And then lastly, the point over 0 up 12. Okay, now I have a 5-sided figure, 1, 2, 3, 4, 5. I'm going to have 5 vertices, so I've got them all. Let's take a look. If I dump these in the calculator, I'm trying to save a little bit of time for us here. I'm going to dump those in the calculator, meaning this. I'm going to put 45. I'm going to dump in the x for x and the y for y. Alright, and of course that's going to be nothing. So let me fill in a few numbers here. For the 10, 3, when I put that in, save some time here, I've got $555. The 10, 0 is $450. The 4, 12 is $600. Okay, and then the 0, 12 is $420. So we can see that she should make and have available to sell, right, for a revenue of $600, 4 hats and 12 scarves. 412. Okay, because X stood for hats and Y stood for scarves. Okie doke. Thanks for watching. Hope you were helped.